This video will be on section 7.2, absolute value functions, equations, and inequalities. So the three topics in here, we'll talk about what an absolute value function is. You're probably familiar with the absolute value a little bit. And what is an absolute value equation? I'll also show you the graph of the absolute value function because it'll help explain what we're going to be doing when we solve absolute value equations and inequalities. One thing I'm going to go ahead and write down here for the notes is there's a lot of ways to do the inequalities. If you watch this video, if you watch the videos on the homework, you might prefer one way to another. They're both correct. Just pick whichever one you like. All right, so what you see in the homework videos is not wrong. It's probably just going to be done a different way than I do it because whoever made them might like doing them a different way. But I like doing them the way I'm going to show you because it's more similar to every other inequality that you solve, whereas the way in the videos will be very special to absolute values. All right, so the definition of an absolute value function and an inequality. The reason that kind of this is in the piecewise function, defined function sections is because the absolute value function, f of x equals the absolute value of x. If you're not super familiar with the absolute value, that it's symbolized by the large vertical bars around a number. The way that it's defined, f of x equals the absolute value of x, negative x if x is less than 0, and x if x is greater than or equal to 0. Which is pretty much the easiest piecewise function there is, because really what this is saying is if your number is not negative, if x is greater than 0, then what comes out is what goes in. If your number is negative, so if x is less than 0, then you just get rid of the negative sign. And like I said, some of you are probably familiar with it. If you're not, you'll just I'll show you how it works by the definition, and then you'll get it pretty quickly. All right, so evaluate the following. The absolute value of 3. Well, since it's positive, it's just exactly that. So the absolute value of 3 is equal to 3. It stays the same since it's not negative. And the second one, the absolute value of negative 4, since it's negative, if we go by the formula, which is how I'll do it the first time, we put a negative on the number. So it's saying negative x. The absolute value of x equals negative x. But a double negative makes a plus, and that equals 4. Right. And for those of you that have dealt with absolute values before, you probably never even did this part. Then you don't need to start doing it now. You just need to remember the absolute value just makes negative numbers positive, and everything else it keeps the same. The only one that sometimes trips people up is 0 because it's not positive or negative, but the absolute value of 0 is 0. For the same reason as the first one, it stays the same because 0 is not negative. And then the last one is just to emphasize that fractions aren't important. The only thing that's important is whether it's positive or negative. The absolute value of negative 1/2 is positive 1/2 becomes positive, but the exact same number. Right? We would never round it. We would never change it. It just, the number drops the negative sign. Right, now what an absolute value equation is, it's any equation that has an absolute value in it. And it's important to make this distinction since these are solved in a not obvious way. So what I want to do is start by graphing the absolute value function for you. So I think we've done this before, but if you go to the y equals menu and then hit math, you go over to the MUM, the number menu, absolute value means absolute, or ABS means absolute value, and you put in X. Now for the older calculators, you'll just get ABS with an open parentheses, and you just put the X inside of there and close the parentheses. All right, but I want to graph this. So hit zoom, go to your standard Windows 6, and you get that V shape. Now the reason I want to graph this is when we solve equations, what's going to happen is we're going to be solving something like the absolute value of x equals 4. Right? If we want to solve the absolute value of x equals 4 graphically, what we would do is we'd have the absolute value of x, and then we would set it equal, the other one equal to 4, and see where they intersect. And you can see it has two answers because it has 2 points where it intersects. I don't even care about the x value right now. For a second, it has two answers. So the way this is gonna help us, when you get an absolute value by itself, or sorry, when you have an absolute value equation, you get the absolute value by itself. Right. So down here the absolute value would be by itself, just to look at this example. Same one I did in the calculator. The absolute value of x, that's by itself. There's no numbers outside of it. And then you'll have a number on the right side once you're there. If the number on the other side is not negative, you'll get two equations to solve, and they'll get two answers. You'll get one answer for each one you solve. And that's exactly what we're seeing here. Because the number 4 is not negative, it's positive, we get two answers. One right there and one right there. Now if the number is negative, how many answers do we get? Let's say -3. Well, it doesn't intersect at all. When the number is negative, you have no solutions. And that's exactly what the second point here is. If the number on the other side is negative, there are no solutions. That's because absolute values cannot be negative. So 99% of the time you solve an absolute value equation, you either get two answers or no answers. Sometimes you can get one, but that's rare. And they can be really complicated, much more complicated than we would ever do in this class, to where you could get more than two. But for this class, 2 or 0. All right, now the way we get the answers is pretty straightforward. I have it outlined here. We set the inside of the absolute value equal to the number and to the negative of the number to solve. All right, so if I go back to the absolute value of x equals 4, if we were solving the absolute value of x equals 4, let me write it on the side here. It has two solutions. We take the inside of the absolute value, which is just x, and we have x equals, we can make two equations, and it equals to the number, which is 4, and it equals to the negative of the number, which is -4. So our two answers for this one would be 4 and -4. If I graph it, if you see where they intersect, this is where x is -4. Certainly looks like it intersects at -4 and at +4. You can actually do it on your calculator if you go hit second in calc, go to where they intersect, and then scroll left or right to get close to where the intersection point is and hit enter 3 times. And you see it does intersect at x equals -4. You can go over to the other one, second calc, go down to intersect again, and then scroll over. Oh good, I can just hold it down. Just get kind of close and do the same thing. You can see it intersects at x equals 4. Right, but it's very important that you make this distinction in step 2, because if you just set the inside of the absolute value equal to the number and negative of the number when it's negative, you can still get 2 answers, but they're both wrong. But you have to make sure you really focus on that. So you got to make sure the number is positive. Okay. All right, so that's kind of our background why we're going to have 2 answers or 0 when we solve absolute value equations. And I just have a few examples here. The first step to solving any absolute value equation is get the absolute value part by itself. And now that you can see 2 problems here, I can explain the difference. This absolute value part is by itself. You can have anything you want inside the absolute value. Just make sure that everything on this side, the left side, is inside the absolute value. You can't just shove stuff in there. What's inside stays inside, what's outside stays outside. So this one would be good to go from the start. It's sort of like a square root. You can only take stuff out of square roots if it's very special, but absolute values are even more special. You don't want to do that at all. Let me make that more. Do not move things inside or outside the absolute value. I'm just going to go ahead and write ever. I don't think I've ever done it once, and I've done a lot of math. Okay, so the first problem here, the absolute value of 3x minus 7 equals 2. The absolute value is by itself. Once we see that it's by itself, we look at the number over here. Is this number positive or negative? Since this is 2 is positive, what we do is we make the 2 equations and solve them. All right, so all we do is we take the inside, 3x minus 7, set it equal to the positive of it, and 3x minus 7 and equal it to the negative of it. All right. So always take the inside the absolute value and adjust the sign over here on the 2, on the number. Now you solve each one of these, just like kind of think about this as like you factored, you made your 2 things and you set them both equal to 0. Now we solve both. So on the left here, we add 7, we got 3x equals 2 plus 7 is 9, and divide by 3, and we get x equals 3 for one of our answers. And then the one on the right, you do the same 2 steps. We add 7 to each side. We got 3x equals negative 2 plus 7 is 5. Divide by the 3, and we get x equals 5/3. And like I mentioned before, you should get 2 answers most every time. The only way you're going to get 1 answer is if this is a 0. Because the difference between 0 and negative 0 is nothing. They're the same thing. So we got our 2 answers of 3 and 5/3. Not negative. Let me get rid of that. So as you can see, there's a few things you don't want to do here. The common mistakes I see is someone just gets rid of the absolute value bars, sets it equal, and solves it like this, and then says the other answer is negative 3. Well, that's not true, because we see the other answer should be 5/3. But another thing is people often want one answer to be positive and one answer to be negative, so they'll make one negative for no reason. that's not what you want to do. These are our two answers. All right, so next one, we'll have to actually do some work to get to the first step. This one will really outline that if you don't do the correct thing first, then you'll just fall off the cliff. So first we got to do is get this absolute value part by itself. At the start, if this isn't by itself, I don't care if the number over here is positive or negative, because it might change when I get it by itself. All right, so I'm going to rewrite the problem. And I want to get this by itself. One thing I want to mention is we've seen things like this, kind of like 4 minus 5 times something. Anytime you have one number is by itself and one number is attached to something, you cannot combine them. The 5 here is attached to the absolute value bar, the 4 is not, so we cannot make this -1. You have to get rid of the -4 first. So subtract the 4 on each side. We got -5 times the absolute value of -8x minus 8 equals -4 minus 11 is -15. And then divide each side by the -5. Right, imagine if this thing was just x, how would you get x by itself? That's exactly what we're doing. We divide by the -5 and we get x, I already confused myself by thinking it was x. We get the absolute value of -8x minus 8 equals -15 divided by -5 is +3 because the negatives cancel. Now that we have the absolute value by itself, then we decide what we should do next. Right, since this is by itself, we look over here. Is the number positive or negative? And we can clearly see 3 is positive, which means we make our two equations. And so we set the inside, -8x minus 8 equals 3, the number, and -8x minus 8 equals the negative of the number, and solve each one of these. Right, so we add 8 to each side, we get -8x equals 3 plus 8 is 11, and divide by -8. And we got x equals -11 over 8. That doesn't simplify. Then the one on the right here, do the same two steps to get x by itself. We add 8 to each side. -3 plus 8 is 5. And then we divide by -8 again. And we get x equals -5/8. So this one, once again, as we should expect because we made two equations, we have two answers. This time they're both negative, and that's just fine. -11 over 8 and -5 over 8. Okay. All right, so just kind of to backtrack, the reason why you have to get the absolute value bar by itself is if you just looked at the beginning and saw this negative, the deception here would think, oh, I have a negative number here. Well, there must be no answers. But we can see that there are two answers. You have to get this by itself. You have to get the absolute value part by itself first. All right, and then the last one of the equations here, same thing as before. We want to get the absolute value part by itself. I don't care what the rest of it looks like. If it's not by itself, we need to do that first. Right, so just do exactly what we did before. I'm going to rewrite it so we have room to work. For the same reason as above, the -3 and 5 cannot be combined because the 5 stuck on this, so we've got to add 3 to each side. And we get 5 times the absolute value of negative 4x minus 9 equals negative 43 plus 3 is negative 40. And then get the absolute value part by itself by getting rid of the 5, divide that over. Get the absolute value of negative 4x minus 9 equals negative 40 over 5 is negative 8. And now we finally ran into an example where the number over here is negative when the absolute value part gets by itself. So what does that mean? That means there are no solutions. There's nothing else to do here. If you solve it, if you set this equal to this and the opposite sign, you're going to get 2 answers that are both wrong. All right, that's again another important thing. I intentionally chose 2 problems here where we had negatives on both sides, but you can see when it works out, one has 2 answers, the other one has no answers. And then on the homework, like always, we have D and E for no solutions. All right, now the last little section builds on this. It's the absolute value inequalities. And like I have outlined here, to solve almost any inequality, the strategy is the following. We change the inequality to an equal sign and solve that equation. So what we'll do on this first one is switch this less than, it doesn't matter which one it is, to equal and solve that. Make a number line and mark off each of the numbers from the previous step. And then this is kind of the third step where we have many ways to do it. I'm going to show you how to do it one way and then another way, a couple different ways on the problems here. One thing that's important to mention here when you solve inequalities, which you did when you found the domain of a square root function, the answers to inequalities are always intervals and they will have to be written in interval notation. Sometimes we can come across inequalities with no solutions, in which case you still write D and E. There's not a special interval way to write D and E. All right, so what we'll do is just outline the steps here. Step 1, we're going to change our inequality to an equal sign to x, absolute value 2x plus 3 equals 5 and solve this. Now, this is only going to be part of our work, but for absolute values, this is definitely the main part of our work. Okay, so let's go ahead and solve this. We have the absolute value by itself. And the number is positive, which means we make 2 equations. We have the inside 2x plus 3 equals 5. And we set the inside equal to the negative number, 2x plus 3 equals negative 5. And solve each one of these. Subtract 3 from each side, we get 2x equals 5 minus 3 is 2. Divide each side by 2, and x equals 1. That's one of our answers that we're going to put on the number line. And then the other one, subtract the 3 off. We got 2x equals negative 5 minus 3 is negative 8. And then divide by the 2 to get x, and we get x equals negative 8 divided by 2 is negative 4. Right. So for absolute value inequalities, that's usually the long step. For other inequalities, this might actually be the short step. But absolute value inequalities, it is usually the longest step. In part 2, we make a number line and mark off each of the numbers here. This is really to organize your work. You could actually figure out the answer just from this, but I do not ever recommend that. I highly recommend making a number line. And we mark off our two numbers, mark them off in order, meaning put the smaller one to the left and then bigger one to the right. Right, and then the last thing here to do. All right, there's two ways to do this. I'm going to show you the first way with this one, and then I'll show you the other way with the next one. You'll probably like the second way more, but I'm going to show you both ways because it's important, and you can choose which one you want. All right, what we do is we plug in a number in each interval. Okay, so these are like our dividing portions of our interval. -4 and 1 divide the number line. Right, so what I want to do is pick a number to the left of -4, -5. Pick a number between -4 and 1. I always pick 0 if I can. And then pick a number to the right of 1, and I'll pick 2. And these are what we're going to plug into the original inequality. Right. Original meaning the last step before we set it equal, but we didn't have to do any work here. And we're just going to see if we get it to work out. All right, so we start by plugging in -5. To our inequality for x. What I'm going to do is just simplify this and see, is this less than 5? Right, so anytime you're simplifying numbers inside an absolute value, just simplify the number inside and then do the absolute value. So if you're not familiar or comfortable working with that, simplify the inside first and then do the absolute value. Okay, so the inside, 2 times -5 is -10 plus 3. And -10 plus 3 is -7. All right, we simplified the inside on down to one number, and now the absolute value of -7 is 7. Now, is this less than 5? Because that's what we want to check. Is this less than 5? No, this is not less than 5. So what I'm going to do is above -5, I'm just going to write a no. And now I'm going to plug in 0 and 2 and do the same thing. So plug in x equals 0. To the left side here, we got 2 times 0 plus 3. 2 times 0 is 0 plus 3. Remember, do not ever split up the absolute value. You must get the inside to be one number. And 0 plus 3 is 3. The absolute value of 3 does equal 3. And then is this less than 5? Because that's what we're comparing it to. And this is yes, 3 is less than 5. So what I'm going to do on my number line is where 0 is, I'm going to write a yes. And I'll explain what the yeses and no means after we get the last one. All right, so the last one, x equals 2, we want to plug in. So we got 2 times 2 plus 3. 2 times 2 is 4. So we got 4 plus 3 inside, which is 7. And the absolute value of 7 does equal 7. And then ask that question one more time. Is this less than 5? No, 7 is not less than 5. I'm going to write a no above. Okay. Now what the yeses and no means, they tell you which intervals to use. So since we have a yes here, we will use this interval. Right, so that means I don't really care where -5 is. -5 being to the left of -4, I'm not going to use. Where 2 is to the right of 1. I'm not going to use. I'm only going to use this one. So I'm going to use where 0 is. I'm going to shade it in to make it more obvious. I want to use the interval -4 to 1. And then the last thing, anytime you use interval notation, when you're solving an inequality, you ask yourself, do I use a parentheses or a bracket? And this, we're going to use parentheses because no equal part. So we got parentheses, the interval -4 to 1. And that's our final answer. Now, once again, I will go ahead and say that this is the longer of the two ways. And in general, anytime you solve an inequality, you have to do it this way. On the next one, I'll show you a special way to absolute values. But one thing I wanted to do this for is that you'll notice that we were solving a less than. When you have a less than, you're going to use the inside one. When you have a greater than, we're going to end up using the outside too. Right? But you have to make sure you have your inequality simplified first. And wanted to show you how to do it all the way. Now with the second one, same directions. We want to solve the inequality. The -3 times the absolute value of x minus 5 is less than or equal to -9. All right, this one, you want to do one thing that we didn't have to worry about at the beginning of the other one, and that's get the absolute value by itself, just like we did with the inequalities. All right, so I'm going to rewrite the problem. And just like I would with the equal sign, when I want to solve it, I want to divide off, get rid of that -3. Now, one thing to remember when you have inequalities, we divide it by a negative number, so we have to flip it. Right. If we have an equal sign, which we do here, that stays. We just flip the way the mouth opens. Less than becomes greater than, and then -9 divided by -3 is 3. Once you are here, you start really solving like we did before. All right, the one thing I like to say is once you have it simplified, you kind of throw away the original problem because this is the simplified problem. Right, so what were these steps to solving the absolute value of inequality? The first step is change to equal and solve that. And once again, use this one, don't use this one, because you did that work to make this simplified. We've got the absolute value of x minus 5. We're going to set it equal to 3. Since you got the absolute value part by itself, that's already going to be done for you. And then the number we can see is positive. So we make our two equations. we have the inside absolute, no, I don't want to write the absolute value anymore. We take the inside x minus 5, we set it equal to the number, and then the x minus 5, and we set it equal to the negative of the number. And yeah, solve each one. Each one you just have to add 5. There's no number on the x, which is good. So we get x equals 8. And if we add 5 to negative 3 on the right, we get x equals 2. Right, then the second thing we do is we make our number line. So we find our numbers, make our number line, excuse me. Mark off our 2 and our 8, which are the dividing lines like we had before. But now that I have that shortcut that we talked about before, this is going to be where we have less than, between, if we're solving less than, and then if we're solving greater than, we use the 2 outsides. Right, so you can plug in numbers again, but this makes it a lot shorter. I want to reiterate this is special for absolute value equations. It is not true for other inequalities. But here, since we are solving greater than, remember to use this one right here. We are solving greater than equal to, so we want to use the outsides. And we want to use brackets because we have an equal part. All right, so let's go ahead and write down our answers. All right, so we're using the outside, we're using to the left of 2. It's going all the way back to negative infinity up until we get to 2 with a bracket. We have more than one interval, so we got union, and then we have to use a bracket starting at 8 all the way forever to infinity. And just as a reminder, infinities always get parentheses. When we say brackets, we mean only on the 2 and 8. But once again, if you want to plug in numbers like, 0 and then 4 and then 10 or something and check them that way, you can check it as well. It'll work. Right. So it's up to you how you do it. And then, like I said, the videos probably have another way. They try to make the number line right away from this. I will warn you that really what they're doing is just solving to get these numbers and then doing the same exact thing. It just looks different. I think this way makes more sense to me. That's why I show you this way. But also makes you practice solving the equalities. All right, so the last two here are kind of like these special examples. What do we do with an inequality if there's a negative sign? All right, so this one, number 3, we have the absolute value of x minus 7 is greater than or equal to negative 3. The absolute value is by itself. And as we talked about before, negative numbers here means no solutions for the equation version. Meaning if we solve the absolute value of x minus 7 equals negative 3. Right. So there's 2 possibilities here. The fourth one is the other possibility. What happens So two possibilities when the equation is D and E. This actually goes for any inequality as well. Your answers are either all real numbers, infinity to infinity, or no solutions, D and E, are the two possible answers. Now, how do we figure out which one it is? There's two ways to do it, but with the absolute value, it's easier to understand the way I'm going to show you. The inequality is going to tell you which one to use. What this is saying is the absolute value of a number, right? If we plug in anything for x, like 10, we're going to get out a number. When is the absolute value greater than or equal to -3? Well, the absolute values are always positive. So it's always greater than or equal to -3 since the absolute value is positive. If it's always, that's our all real numbers. Our answer works for no matter what x value we use. And the other one here, D and E, is when it would never work, which we'll see in the second one. Right, but this first one, the answer is all real numbers, infinity to infinity. So just comparing this, number 3 to number 4, we go through the same steps we always do with absolute values. We want to get this part by itself, which we have. We check out the number over here and see that it's negative. So there's going to be no solutions to the equation. And as we saw in the previous section, it doesn't matter what's inside. It can be pretty messy. As long as that number is negative, there's no solutions. So we look at the inequality to determine our answer. This one's asking us, when is the absolute value less than -8? And the answer in your head should be, it can't be less than -8 because the absolute value is always positive. So this is never, which means there are no solutions for D and E. Right, this is kind of the tricky example, I guess you could say, of this section, because whenever you solve an inequality, it's very much follows the same structure every time, but with absolute values, since they can't be negative, you have to be careful about the negative signs over here. But that's all the possibilities we have.